All right. Hello, class. This is Mrs. Lyons. Today we are going to talk about net ionic equations. Okay. And before we get into what that means, we are going to just kind of look at our solubility table for a minute. And we are going to look at, we're going to identify these compounds as aqueous, meaning that they're soluble and dissolved in water, or insoluble, which means they would be a solid. Okay, so we're gonna kind of just start using our solubility rules. So compound number one is copper chloride. So if I look, I see here all chlorides are soluble except these. Copper is not listed. That means copper chloride is going to be soluble in water. Chromium oxide. So let's see what we got. Down here, if you look, oxides are insoluble unless they're with one of the group 1 metals or ammonium. So if oxide, what was our compound? Our compound was chromium oxide. So that is going to be insoluble. So we would write solid. Okay. Iron 3 sulfide. If I look at my solubility table, sulfides are always insoluble, except, of course, those few exceptions, and iron is not one of those exceptions. All right, so iron 3 sulfide would be a solid, insoluble. Copper 2 sulfate. So if we look here, sulfates are always soluble except copper, strontium, barium, and lead. So that means copper sulfate is going to be soluble. So we would designate it AQ. All right. Aluminum carbonate. So if we look at our list, carbonates are insoluble. So aluminum carbonate would form a precipitate, is what we call it. It's a solid, insoluble. Magnesium phosphates. Phosphates are also on our list of insoluble compounds. So that means that magnesium phosphate is insoluble, so it forms a solid precipitate. Barium sulfide. Sulfides also are on the insoluble compounds list. So barium sulfide would be a solid. And then the last one is silver chloride. So notice, okay, so up here on our soluble compounds, chlorine, bromine, iodine, chloride, bromide, iodide, are all soluble except when they're with silver, mercury, or lead, which means silver chloride is going to be insoluble. It's going to form a solid precipitate. It's not going to dissolve in water. Okay, so that was just a little practice in terms of remembering how to use that solubility table a little bit. Okay, so what we're going to talk about today are net ionic equations. Okay, in a net ionic equation, and I guess we can write this, only compounds that react are shown. Spectator ions are not included. Okay, so this idea of net ionic equations kind of builds off of what we talked about with double replacement reactions, and it is based on the fact that one of our products in a double replacement reaction is going to be a solid. Okay, so what we do is we start with our complete balanced double replacement reaction. Okay, and I'm not going to rewrite that because I've got it right up here. Okay, next thing we do is we rewrite the equation. For each aqueous compound, you're going to separate the ions. Okay, now what I mean by that is barium nitrate is aqueous. I'm going to break it apart into its ions. Okay, so this we have to remember our charges. So barium is a +2 ion. I'm going to put aqueous. And barium nitrate is made up of barium, the barium ion, and it's got 2 nitrate ions. That's what that 2 means. It only applies to the NO3. So 2 NO3 ions that have a -1 charge. I'm going to say those are aqueous. Okay. Plus sodium, we have 2 sodium ions. The little 2 tells us we have 2 sodium ions. Sodium is +1. So we're kind of doing the reverse of combining ions. Okay, if you want to think about it that way, that's really what doing a net ionic equation is doing. So 2 sodium ions plus a sulfate. So we've got SO4. And SO4 has a -2 charge. Okay. And then we're going to go over here and we're going to have our products. And I'm going to put those down below because I don't have enough room to write. Now, the one thing that I guess it doesn't really say here, but when something is a solid, we do not separate it. Okay. What that means, it being insoluble, means it can't break apart into the individual ions. So we are going to have BaSO4 solid, and we're going to keep it that way. Plus, and then sodium nitrate is aqueous, so we have 2 sodium ions plus 2 nitrate ions. Okay. So now the next thing that you're going to do is you're going to cross out any ions that appear, let me slide this up, that appear on both sides of the reaction. Okay, so anything that is exactly the same on both sides of the reaction. Okay, so here, barium +2. Do we have that on this side? We don't. What about 2 nitrate? See, we've got 2 nitrate over here, so we can cross those off. Use a different color ink. 2 sodium and 2 sodium, so we're going to cross those off. Okay, and then sulfate, we don't have a sulfate ion on the other side, we just have the solid. Okay, so what we're going to do is, I guess I gave myself too much space for this. We are going to rewrite the equation as it is without these extra ions. And these extra ions that we crossed out are called spectator ions. And what that means is they're dissolved in water on both sides. They really don't matter in the reaction. What matters in the reaction is that we start with barium +2, and we combine it with sulfate -2, and what we make is barium sulfate solid. Okay, so this is our net ionic equation. Okay, all right, let's try to do one all the way from the beginning. Okay, so here we have calcium chloride and silver nitrate. So remember, the first thing we're going to do with a double replacement reaction is we're going to underline the anions, and then we're going to switch them. So we're going to end up with calcium nitrate plus silver chloride. Okay, now we want to look at our products on the solubility table. So calcium nitrate, all nitrates are soluble. Okay, so calcium nitrate, I'm just going to put this here, we'll rewrite it, would be aqueous. Silver chloride, however, remember chlorides are always soluble except when it's with silver. So silver chloride is going to be a solid. So now I'm going to go back and I'm going to write my whole equation. Okay. Calcium's +1, chloride is -1, silver is +1, nitrate is NO3 -1. Okay, so let's see. I have, calcium's +2. I don't know what I was thinking. Calcium. So we end up with CaCl2 aqueous plus AgNO3 aqueous produces calcium nitrate, so CaNO3 aqueous plus silver chloride, AgCl solid. All right. We need to balance this. So I've got 2 chlorines over here. So if I put a 2 here, that gives me 2 chlorines, 2 silvers. Ooh, this should have a 2. So we have 2 here. Okay. So now that we've got our balanced chemical equation, we're going to break it down into its ions. So we have Ca plus 2 plus 2 Cl minus 1 plus 2 Ag, 2 silver ions, plus 2 nitrate ions. All right. And those react to give us, let's see, we have calcium still. So calcium plus 2 nitrates with a -1 charge. Plus, then this is our insoluble compound. This is our precipitate. So we're going to leave this as 2AgCl solid. All right. Now I'm going to look and see what I have on both sides. So I have calcium on both sides. So I'm going to cross through calcium. I have chloride, but chloride's part of the compound over here, so I can't cross through that. I can't cross through silver, but I can get rid of the 2 nitrates. So now my compound, or my net ionic equation is, I'm going to have 2 chloride ions plus 2 silver ions. And those are going to react to give me 2 silver chloride. Okay, so basically, net ionic equations, you're breaking things apart. Anything that's aqueous, anything that dissolves in water, you're breaking it apart and then canceling anything that appears on both sides, so that when you get down to it, you simply have what's really happening in the reaction. Okay, and in this case, if I asked you what the spectator ions are, you would tell me that calcium is a spectator ion and nitrate is a spectator ion. Okay, let me mark those. Meaning that they're just watching. They're not participating in the reaction. All right, so that is a quick lesson on net ionic equations. I hope you find that helpful. I will see you in class. Take care of yourself.